Good evening, guys. Hope you people are doing very well, and thank you so much for seeing a lot of videos about in our PyData Explorer. I already launched yesterday the videos of the Matplotlib and the Seaborn. Both the videos are doing the plotting the dataset, and today I am just going to explain about the Plotly. This is also another beautiful library of the Python so that you can make a beautiful representation of the data and you can take some insight from the data and you can just increase your sale of any particular company or the organization. But before that, if you want to do these kind of things, so this Plotly will help you to plot those kind of the data. So earlier, just before 20 years or the 15 years back, people used to use the Excel sheet. Excel is a huge sheet where the people can explain about their data, and that is looking more monotonous if you see the Excel data sheet. But nowadays these are the tools where you can make beautiful plot. But I know that the Power BI and some other tools is also there to represent the data, but Plotly also helps the in the data science field a lot to make the data set. So I just want to discuss about how you can install Plotly in your system. How you can do that? You just write down that pip install Plotly, then you can just run that one, and if you run that one, you can see the Plotly is already downloaded in your system. Sometimes it may be you need to download the couplings as well. So if you just want to download the coupling, what you have to write down? Again the same command, pip install coupling. Then if you just run the program, then the coupling will be automatically downloaded in your local system. Then I just import the pandas, numpy, matplotlib, cvon, and a plotly offline import iplot, and this is the key line, import plotly as py. So by writing these lines, I just import some of the beautiful libraries which will help me to make a beautiful data representation. And plt.rc params, I'm just taking the figure size dot figure size is equal to 10,6. That will be the plotting size. I will explain it when the plot will be going to be displayed. So in here I just write down py dot underscore underscore version underscore underscore. If I run that one, then we can see this plotly is basically 5.22.0. In this way you can just check the version as well. Now I just write down py.offline.init underscore notebook underscore mode. Within first bracket I am using connect is equal to true, and then cf.go underscore offline first bracket, so that they can directly fetch the data offline as well, and they can make the plot from that dataset. How we can do that? That we can later on check it. Then if I just write down the pwd, this pwd, if I run that query, then you can see the location. You can location of the dataset from where this actually my file, this data visualization hyphen part 2, this file is located. It is located basically in my local system in the downloaded file. So if you want to check the file location by writing pwd, you can check it. Then directly, like the cvon library, some of the dataset is also included in the plotly library. So if we want to fetch that dataset, how we can do that? We just write down sns dot load dataset, and within first bracket and within inverted comma I just write down iris. Then I just run the df1, this variable. Then if I run that one, then we can see we are just getting the iris dataset in here. This is the total iris dataset. So in this way you can fetch the dataset, and another way it is also available from where we can see the dataset and from where we can download the dataset as well. So that is basically, if we just go in the Google and type it the iris dataset in Kaggle, if you want to download from there, so you can see in Kaggle you can just get the iris dataset. And from there one download button is there. If you click on that download button, then this iris dataset will be going to be this iris dataset iris.csv, that is the size is 5.11 KB. That dataset will be going to be downloaded in your system. And if you want to see that how and what about the iris dataset, if you just go in the Google and type the iris dataset Wikipedia, then just go in Wikipedia page in the iris dataset, then you can just get to understand all the details of the iris dataset is available in the Wikipedia page as well. So let's see that how the iris flower it looks like. This is there are three types of the iris flower is there. Iris flower, the first type is the iris setosa. This is the iris setosa. This flower is iris setosa, and this category is called iris versicolor. It looks like some beautiful purple color is there. And this one is the iris virginica. This one is the iris virginica. Guys, if you observe these three flower, then their sepal length and the petal length is the quite different. So by which the machine can understand that in human eyes you can easily differentiate these three flowers. But if you want to take this data set, you cannot, the machine cannot identify which flower it is, which prototype it is. So for that the machine is using the dataset that is called sepal length, sepal width, and the petal length, petal width. What is these things? I will explain you when I just go in the dataset. So let's go in the dataset directly. So in here there are some, this column are using here sepal length, sepal width, and the petal length and petal width. Then according to this column, according to this variable, they are just identifying which category of this flower, of the iris flower, whether it is setosa or whether it is virginica. So I already told you, in the machine they cannot understand without seeing the features. So basically these are the features. So according to their features, when I will just make the videos of the ML machine learning, then you can understand when we are just giving this data set and train that machine learning. Then after that we are just giving some of the length, and then machine will automatically predict that which kind of data set or which kind of flower it is, whether it is setosa or the virginica or the versicolor. Then if I just want to plot, if I just write down df1.plot function, and basically what it does, it looks like more like the line plot. So if you just write down, if you run that program, then you can see they are just taking the four column. Which are the four column? These are the sepal length, sepal width, petal length, and petal width. This four column, they are just taking it and make it plot it here. This is basically the plotting areas. This is the basically plotting areas, which I already write down in this line. This is the plot figure size 10,6. So in here in the line chart, we can easily understand this blue line. Blue line is basically the sepal length, and that this orange line, this is the sepal width, and this green line, this is the petal length, this green line, and the red line, this is the petal width. So same thing, we can just expand the size of the plot, and we can easily understand the same thing. These are the same thing: sepal length, sepal width, petal length, and petal width. Now, if we want to check that, suppose we have one restaurant, if we have some data set about the sales and the revenue in our restaurant, so we are just taking, just for an example, the 4 months: January, February, March, and April. And in the sales, suppose these are the lakh: 2500 lakh, 300 to 3200 lakh, 3100 lakh, and 2700 lakh. Suppose if we consider this one as a lakh: 2500, 3200, 3100, and 2700. And what about the revenue? If we just think that these are the revenue, that 8000, 1000, 9500, and 8500. Suppose if I just have the month, 4 months, I have those months sales and the revenue. If we want to represent those one in a diagram, then how we can do that? We are just taking the layout, this variable. Within layout, I am just passing some of the variable. The first variable, that is the plot underscore bg color, that is the black. Which one is that? This is the plot background color, that is the black one. If you change, instead of using the black, if you make it white, then the color will be white here. And then the next variable, that is the paper underscore bg color, that is the blue. Which is the blue? This area, this is called basically the frame of this data plotting area. So in the frame, instead of using the blue, if I am just writing down in red here, then you can see this will be the going to be red, and the font is color is white. What is the font? You can see the 10K, 8K, 6K, 4K, these are the font color. If you change the black color, that will be going to be black. So I already provide you this notebook, guys. You can change whatever I am just telling you according your choice, and you can just run the program. Then you can see this plot will be going to be changed their color. Why I am not doing right now? Because this video will be going to be too long if I change all the variable and if I just run all the things. Then I just plot it. df1.iplot, I am just using the month. I am in x-axis, these are the month in x-axis, and the y-axis I am using the sales and the revenue. In this is the y-axis, I am just putting it sales and revenue. Then kind is the line plot, and I am using the, this is the line plot here, and the title, it is for the deep blue color, so we are not able to see the title of the dataset. That the written is there, monthly sales and the revenue. And then we are just make it layout. In here we can see that orange line is the sale and the blue line is basically the revenue. If you plot this line, then you can easily understand in the month of the January what is your sale condition and what is your revenue condition in the March and the April. If you see the orange line and compare with the blue line, you can easily understand that in the month of the February to March the sale was up, and the from the month of March the sale is going to be down. So this is the visual effect from where you can easily see your data set instead of seeing the whole Excel sheet. Now I want to take the random data set. How I'm taking that one? I'm just passing pd.dataframe np.random.rand. This function is basically the numpy function. Random.rand basically create the random number. The how many random number they can create? 300 rows will be there and 3 column will be there, and those column name will be the ABC. Column is equal to ABC. So if I run that program and if I just pass the df here and run that program, then we can see the column name ABC3 will be created, and they are creating 300 rows, 3 columns, if you see it here. So we can generate automatically this much of number, and all the random function basically generate the number from 0 to 1. So this, if you run continuously, you can see that all the number will be going to be changed in every time. Then when we are just plotting those number, those dataset, which dataset? I'm talking about this dataset, df dataset. If we are just plotting this dataset, then you can see this is too much hazy in the line chart. So many line charts are there. So in this particular case, basically line chart will not actually help this case. So you have to understand that which particular plotting actually help you to represent your dataset. So I am just explaining a lot of different type of the plotting, how you can do that, but you have to understand as a data scientist which plot you have to use in which location, so that some data and the problem statement that can easily identify. And again, these things I already discussed, which is background color, which is front color, and then in here this point I already explained in this program. Now I am just discuss about the scatter plot. If I am taking the same data frame and df.iplot is equal to x is equal to a and comma y is equal to b, then mode is makers. And here in x-axis I am just taking the a point, and the y-axis I am just taking the all the b point, b column. Basically I am just taking a column and b column. These are the a column and these are the b column data set. I am taking that one, these two, and then I just use the mode is equal to markers. So if I am just writing down here mode is equal to markers, then I just run the program, then we can see the distribution of number we can easily identify in different location. So you can easily understand why the dataset is spread and how the dataset is spread. But if you see this chart, you cannot interference any of the number. And most interesting things is that if you just hover means if you just click or just go your mouse, it goes on that particular point, then you can easily understand which point it is. You can see 0.2839 comma 0.971. If you change that location, that point is automatically shows that that mouse point. So you can easily identify which point it is. If you change the point mouse area, mouse pointer, then you can see the all the data point x and the y point. You can see it here, 0.099 comma 0.020, it's here. Now I am just taking the Titanic dataset. So I already told you this kind of dataset is already pre-installed in Plotly, same like the Seaborn. So if I'm just writing down sns.load underscore dataset the Titanic, then I just run that this variable the Titanic, then we can get this dataset. So which kind of dataset it is? It is basically the Titanic, which already the accident already happened more than 100 years back. The great ship, it was thrown into the sea, and in the sea so many plenty of people they had died in that accident, and some of the people they already got alive. So that dataset right now it works right now today as a data scientist field. So basically in the survive column we can see different column name it is there. In the survive column we can see 0 and 1 it is there. 0 is basically expired or the dead, and the 1 is survive. And the P class in Titanic there are 3 classes now, 1 3 and 2, 1 2 and 3, these 3 classes it was there. What is the sex? Sex is basically male and the female. The age group it is also mentioned here, and then we can see the fear in according to the level. In the number 3 class, that is basically the cheapest class, and the number 1 class, the first class, that is the expensive class. You can see it here, £7 and £71 here. And after that, embarked basically is the place name from where the passengers board on the sea. Is for Southampton, C for Salzburg, and Q for Queenstown, this one. And these are the class name. This is all about the Titanic dataset. Now, if we just do the scatter plot on that Titanic.iplot x is equal to fear, in x-axis we are just taking the fear, and y-axis we are just taking the age group. Then mode is makers, comma x title is fear, and it is x title is fear and y title is age. So in the x title you can see that this fear it's written there. In y title we are just mentioned the age here. So you can see the distribution of the Titanic dataset. This is this dataset, all the point is distributed here, and from this distribution, as a data scientist, we can see this is basically outlier. Outlier means that is not comes in this group. There are basically only 1% it is there who paid more than $500 for boarding the ship, but in maximum you can see in this area between 45 till in here 46.9, in this particular area most of the points are there. That basically means the age group of till 20 to 40, suppose 10 to 40, they are using in this area, and they are paying approximate £50, 40 less than £50. So basically that means people are preferring on the ship, these are the less price ticket. Basically they are just going for the third class. And above 50 age, you can see in this area above 50 to till 80 age, people are spending more money in this area. If you see that people are spending more money, that is normal, because somebody is more than 50 years, they already have their more money in their pocket, so that's why they're just spending more money on board the Titanic. But as a data scientist, if you are working in suppose XYZ, any of the shipbuilders company, suppose they are making also the huge ship like the Titanic. So which kind of focus or what you learned from this dataset in here, we can easily understand for the youngster people, they are preferring basically the cheapest ticket. So if you just want to make this kind of the ship, so your capacity is more focused on the cheapest area, because this kind of population and the crowd is more. So that is your key area where you can focus on that. So basically data always talks about that, and as a data scientist, after plotting that kind of data, so you have to interference some of the point so that it can increase your business. That is your key purpose. Basically company will just give you a problem statement or the data set, and you have to plot that one, and your plot, according to the plot, you have to understand what actually the data is saying the original information. In the modern area, every business is like a data, like Netflix, Amazon. If you see, they are just selling their product by understanding the which kind of customers they are looking for the which product. And in the Netflix and the YouTube, and which kind of customers they are seeing the horror movies, or seeing the playing football, or the seeing the match, seeing the different serials. So according to them, they are just suggesting to that kind of client, so which kind of product they are liking. So basically you have to learn how you can utilize which plot, and from that plot you what you learn from what you learn means what the dataset actually mean for that, which can increase the sale. Now I am using the box plot. I already explained in earlier what is the box plot. Box plot is basically the statistical interference. What is that? In this area, if you hover on that box plot, you can see this point is basically the minimum point. And in this box, this is basically the quarter one Q1. This is basically the 25%. This is the median point, that is the 50%, and this is the 75%. And this above, that is the maximum point. So if I just plotting this data set, so we have to understand in this particular area, means in mid area or the median area, most of the data set is present here. But as a data scientist, it will not work a lot on this particular case. Might be when I am just making the email videos, then you can understand what is the importance of the box plot. But as of now, you can see they are taking the three different box. They are using the three different box, and all the data set is basically lies here. All the 50% data is lies inside this box area. Now, to understand this kind of box, I am just using one data frame, pd.data frame, and I randomly I'm just putting these are the numbers, this much of numbers, and I just want to make it in a box plot. I just use df.iplot within first bracket kind is equal to box. That means that makes the box plot. If I run the program, then we can see this box plot can be generated. But in here again, you can see that this is the 0th point, and this in this box, this is the first quarter 25%. In mid, this is the median point, and this one is the 75%, and this is the maximum point. So basically it shows, this box basically it shows most of the point, most of the number I am using in between 1 to 10 or 1 to 20. Most of the data set is belongs here. So you can see the data set, most of the number sets belongs here, but 110, 111 and 101, these are the maximum number that lies in this particular area. So basically you have to understand, after seeing the box, the maximum your data set is present inside this area, 25 to 75% in this particular box area. Most of the data set, 50%, more than 50% data set is present inside it. Now basically I am just discussing about a 3D scatter plot. That is also looks very interesting, but in a practical world, guys, it will not help you, because in the business world, but just for the learning purpose, you just see this plot. I am using that df.iplot is equal to x is equal to 1 and y is equal to b. I am just taking all those previous data set a, b, and z is equal to c. That kind is equal to scatter 3D. If I am just passing within first inverted comma, if I just run the program, we can see we are making the 3D plot. Then if you are just round, if you are just hover your mouse inside here, and if you are just change the location, you can see whatever the position of the data, x what is the point, y what is the point, z what is the point, and how many numbers are there, you can see within this scatter 3D plot. But guys, remember again, this kind of plot is never used in your day-to-day work. Now again, I am just taking the Titanic dataset. I already explained just 2 minutes back. Then I am just using the 3D scatter plot on that dataset, on the Titanic dataset. How I am using that one, so you have to understand that one. So I am just taking the layout. I am just is equal to scene and I'm just passing inside the scene the x-axis, y-axis and the z-axis. In x-axis, what I am using here, x-axis title is here, and the y-axis I am using the age, and the z-axis I am using the passenger class. These are the 1.5 to 2.53. These are the passenger class. And if you just hover here, you can see these are the fare. These are the fare of the ticket fare of the Titanic. And in this area, you can see this is the age group. So guys, remember one thing here. If you just passing it here, you can see all the dataset is lies between 3, 2 and 1. Why it is happen? Because in earlier I already told you the first class is basically the expensive class, and this second class is cheaper and the third class is more cheaper. So in the third class, most of the dataset is present here. Again, this chart and this plot will not help you in your daily work. Just see how you can plotting this dataset in a different kind of the plot. Then this is called the bubble 3D. What is the bubble 3D? If I am using the same Titanic dataset, titanic.iplot is equal to x is equal to fare, y is equal to age, and z is equal to p class, and then kind, that is basically which kind of plot I am using, the bubble 3D, and size is fair. This is the size of the plotting here. So if you see the bubble size, some of the bubbles are little small, and some of the bubbles are big, some of the bubbles are big. So you have to understand that this big bubble are using the bigger point of the dataset. If suppose they are just spending more money in here, then that kind of the bubble will going to be more bigger in comparatively other. If you see in the third class, those are the cheapest class, is all the bubbles are very small. In the first class, this bigger bubble, these are the first class ticket, there this bubble are more. So we can, if we hover that one, then we can easily understand that what is the price, what is the x point, y point, and what is the ticket price. Again, it will help you to understand how to create the bubble plot. And again, I am just telling you this kind of the plot, it is not using in the daily to work, in the corporate work. Now I just want to discuss about the scatter plot. Scatter plot also again a very important plot. How we can do that? I am using the iris dataset, df is equal to px dot data dot iris. In such a way we can just interference the iris dataset, and which kind of data I am just passing it here in the px dot scatter. Px dot scatter I am using the df comma df, basically I am taking the data frame. Then I am in x-axis I am just using the sepal width, and in x-axis I am using the sepal width, and the y-axis I am using the sepal length. In this area I am using the sepal length, and color is spaces. This color I am using the spaces color, and then trend line is OLS, and these are the basically the trend line. Trend line is basically means the best fit line. Then I am using fig.update layout, and I am taking this height and width. Width is 500 and height is 400. What is that? The width and the height, this is basically a height is 500, and width, this is the 400. I am using the plotting. In here I can see in iris dataset in a different color I can see in this plot. The green color is basically classify the Virginica, and red color, red dot point, is the versicolor, and blue color is setosa. So these dataset are lying in such a way. So in this line, we can easily say the setosa's sepal length and sepal width comparatively less than the versicolor and the Virginica. The green and the red point is more than setosa. So setosa, maybe it is looks like thin, and in this data point it says that the highest thick sepal length and sepal width, those may be the category of the Virginica. You can see the position of the dot, and versicolor again we can see this is the moderate kind of the length of this flower it is. So according to that this feature, if we are just trained our model, and then we can understand that which kind of flower it is, basically after seeing the different, suppose the machine don't know which kind of the flower it is. If we train this data set, and after that if we are just pushing it some new data set, then machine can easily predict which kind of data set it is. Now I am using the bar chart, this bar chart. In bar chart, I am using the tips dataset, which I already explained in the last video. In a restaurant, in which time, which kind of the people, the male and female, they used to come, and how many tips they are giving. So in here, I am just using here fig is equal to px dot bar. I am just passing the data frame. Then I am just passing the in x-axis 6. In x-axis, I am using the 6, and the y-axis, I am using the total bill. And bar mode, I am using the group bar. Group bar basically is intact with each other. So after plotting this bar, and this side, the blue color stands for non-smoker for the male, and the red color is non-smoker. Sorry, red color is smoker is male, and in this side blue color is non-smoker female, and red is smoker female. So after seeing this chart, we can easily see that one, the total number of the bill. So male are creating more bill rather than the female. After seeing this chart, we can easily see. And again, another thing I can say it, the male are more smoker if you compare with the female. These two the information that can be easily identified by seeing the chart. So again, as a data scientist, you have to understand the problem statement after seeing the data. Then you have to decide that which kind of chart you want to use it, so that easily you can interference the information from that data. Now this is basically tips dataset. This is basically a tips dataset from where I am just making this chart. Now again, I am just using that dataset, and if I just create this plot, this is called the facet plot. This is called the facet plot. How I'm just making that plot, I'm just taking the tips dataset. Then we can see it here. You can see it here. Px dot bar I am using in x-axis, that is the x-axis. I am using the 6. In this area I am using 6. Y-axis I am using the total number of the bills in y area, this area. Then color I am just using according to the smoker. In here you can see there are two colors used. Blue stands for no and red stands for yes. And the bar mode is grouped. Bar mode is grouped means I am using the bar chart, and the group bar chart I am using here. And the facet row is equal to time, the which time the people are coming here, and the facet color is the day. Facet column, facet underscore column. This is basically that Thursday, Friday, Saturday, Sunday. So in such a way, I am just using this chart, and I am using passing the day Thursday, Friday, Saturday, Sunday. I am passing it here Thursday, Friday, Saturday, Sunday, and time is lunch and the dinner. In here I am using the lunch and the dinner. So if we are seeing this chart, we can easily see on Saturday and Sunday in the lunch time there is no customer. In comparison of the Saturday, Sunday, we can see there are a lot of customers in this restaurant. In here on Thursday and Friday, we can see in the dinner time, in the Thursday, in the lunch time, the sum of the customers is there, and the dinner time there are very less customer. So if suppose you have a one restaurant and you have seen this kind of data, then you can easily understand how you can use the people management, money management, and so that your business can gain more profit. So if you see the Saturday and Sunday, this is the peak hour of that restaurant. So in that time, you try to make more valuable plate or item or the food in this time. You can use more manpower on that time, so that your client or the customers, they can get good service and the good food at the time, so that they can generate more number of the bills, so that your business can be increasing. And in this particular area, in the Thursday and Friday, suppose this is the dinner time, there are very less customers. So in that time, you are minimizing your manpower. You can make less food item in here, so that your cost is more effective. Or in this time, you can take the decision how you can generate the business on dinner time on Thursday and Friday. You can running some offer. You can just call your loyal customers, please come on this, and on this day on Thursday, on the Friday evening time, you can give the buy one get one offer. So you can running this type of the promotions, so that customers can get attracted by that one, and so that they can come and they can generate your own business. So guys, you have to remember that after seeing this chart again, as a data scientist, your point is that you have to find out the business opportunity and the business lacuna. So whenever you are just creating some chart, so that your owner, your manager can identify that which are the problem area by seeing the chart, and how you can increase your business, so that you can get promoted for your next level. Now that is called the scatter matrix. What is the scatter matrix? So if we are just making this kind of data, the iris dataset, I'm using the iris dataset here, sepal and sepal width, petal and petal width. So I already told you in the last video that if you see this is the best fit line, if you see in this corner in x-axis and y-axis, it is goes up in direct way, that is basically positively correlated, that your dataset is positively correlated. And if it is coming in the curve in a negative way, it is not present in this data set. So these are the positive correlation. Positive correlation means your both the condition is going in a positive direction. If your sepal length is increasing, your petal length is also increasing. So both the cases increasing. So in that case, that is called positively correlated. So by seeing this chart, you can easily identify most of your data set. This is all are positively correlated with each other. Now we are again, I'm just taking the IGEST dataset. This dataset again, sepal and sepal with petal and petal width, and these are the specification of those classes. And we can see the species ID. We are just we know that in the machine learning, the computer cannot understand the string value, so we are just taking the one more classes in this data set. The species ID, maybe setosa is equal to 1 stands for the setosa and 3 stands for virginica. In a machine learning time, you have to identify, guys, if you have any string value in your data set, so in your data set you have to change into the integer value, so that the machine can understand the things. And in this data set, if I just make, this is called the multi-dimensional parallel coordinates. If we are using that same data set and I am using this plot, how I am using this one, you can understand, you have to understand this three line, how I am just passing this one, the sepal and sepal width, petal and petal width. Then I am just scaling it here, that color continuous scale, I am just using that px dot color dot diverging dot tl rows comma color continuation underscore midpoint is equal to true. So if I just make this kind of plot, we can easily understand this red is basically species 3. What is the species 3? You can see this is the virginica. And what is the species 1? That is the setosa. This is the species 1. This is the setosa, green color. So by seeing this one, and the yellow color is the number 2 coordination. So if you see in here in the setosa, the number 1 setosa and 3 is basically the virginica. The setosa's petal length and the petal width comparatively less than the segment of the tree, because all the red, this area, the sepal length and the petal width, this is thicker if you compare with the flower type 1. What is the flower type 1? That is the setosa. And what is the flower type 3? That is the virginica. So by seeing this chart, we can easily understand that from which area, which particular article are different. This is green is for number 3. This red stands for number 1 flower, and the yellow stands for number 2. That how it is difference, why they are difference, by using this chart we can easily see that one. Now I am using, and then again the previous tips, the hotel tips dataset, and after using that one, how I am using this plot. This is basically called the multi-dimensional parallel categories. What is the multi-dimensional parallel categories? So you have to understand it. In this column they are using the sex. This is the female, this is the male. And in this column there are two values, no and yes. No means non-smoker, yes means smoker. Day, Sunday, Saturday, Thursday, Friday, this 4 days data is there. Time, dinner and lunch. And the size, this is basically number of the people they are coming there. So if suppose I am just taking this thicker purple line, so if I am just and in here in the size is equal to, they are using the, I already explained in the last video, the color concept, that this light color or heat map, I already explained these things in heat map concept. This light color is basically size number is increasing, and if the color is deeper, the number is less. So if I am seeing it here, that the number of the people of the male, that is the count. You can see if I hover my mouse on that chart, that the 22 people in the male, they are the smoker, and they come in the daytime, and they come in this restaurant on the dinner time, and the number it is count in here, that 22. So in any of the line, if you go that how many customers are there in particularly, if you want to dig drive inside the data that how many ladies coming, they are the non-smoker and they are paying more, and in which time they're coming, all the interference of the data you can just create this kind of the chart and you can easily understand and what time which kind of the data they are coming, people they are coming. Now it is called the bubble plots with hover level. Hover levels, hover means if you go on any of the point, you can easily see that what point it is. That is called hovering. So I am just using that import that plotly.express as px, and then I am using that data dot gapminder. I am using that gapminder dataset. In here, this dataset is basically the GDP growth. This dataset, if you want to check, you can check it in the Google, and in there you can see there are 5 continents are there: Asia, Europe, Africa and Oceania. And on there, that which continent is basically more happy, and which lifestyle is more better, and in which area. So to understand that one, if I am just plotting this one, how I am just plotting that one, just I am using fig is equal to px.scatter, and df.query I am using that year double is equal to 2007. It means I am just taking the 2007 data set. Then I am just taking in x-axis, that is the GDP per cap. This is the GDP per cap, and in y-axis I am just taking the lifestyle expectancy. I am just life experience I am taking here, and to y. Then after that I am just using the size is equal to pop is basically means the population, and color is the continent. In according to the color, different continent are using the different color. If you see, the Asia is using blue, Europe is using orange, Africa green, and so on and so forth. And after that, the hover name is equal to country. But what is the meaning of that? If I hover on that, and you can see the Brazil comes first. In this, the China comes first. So according to the country, the hover, when you hover on that particular point, they will just show that this name, and the maximum size is 30. 30 is using here. So basically, after creating this chart, we can easily see in this particular area, GDP per cap, that is the high in here, and the life expectancy is also high. Life experience is also high. Where this is the United States, and this particular area, and there are some of the European countries, the orange color, you can see their lifestyle is really high comparatively different continent. And if you see this green color area, this is basically the African country. These are basically their life experience is less and their GDP is also less. So by creating this kind of the chart, you can easily understand that which continent is using, located in which position, and how their lifestyle it is. If you hover on that point, and all the details is already mentioned there. And this is basically that same data set which I am using just before that. That country, continent, year, life experience, pop, and pop basically means the population, and GDP percentage, ISO alpha, ISO underscore name, and these things they are using on this chart. This is the data set. Now I am creating one most interesting animation on there. So what is the animation? If I just click on that area, the run, basically this is the year from 1952. I am taking the data set till 2007, and I am just taking the continent in here. If I just run that videos, you can see how beautifully this round balloon, you can see it goes away. It means if you see the Oceania, if you see the 1950s, it was there and it is already life experience is increasing. And if you see in that orange, the Europe, it was already in this position, and they have changed their location. So if you are just creating, if you want to change your if you are using this kind of the videos in your data set, and they are just showing that from where how they are changing it here, and it looks more beautiful of your chart pattern. I'm taking the year, basically animation is animation group I am using here, that is country, according to the country as I am using there, and I am using the GDP per cap. So in there I am just taking the range 102,000 and range 25 to 90. This is the pie chart. How we can do the pie chart? Pie chart I already explained in the matplotlib also. So how we can do that? If you see here, if you see that df.px.data.capminded and query, I'm just taking the 2007 data set. Continent is use Europe. That means basically I'm just taking the Europe continent in 2007 dataset, and in here in iloc in this line I'm using df.log function. Df, I'm just passing the pop means population, where less than 2 crore, and those country they are basically taken, and the country name it will be taken is equal to other countries. And then I'm just try to make it the pie chart. How I'm doing that, px.py, then I'm just passing all the data set, and the values is equal to pop means population, and names is equal to country. Then I'm just using the title. That title is the population of the European continent. This is the basically the title. And how this percentage it comes, you can see they are just checking the total number of the population. You can see 151,288, 511. So they are just make it sum of all the country's population, and they are taking the present country population divided by all the country's population into 100. So they are getting the percentage, and in such a way they are taking the different color of the different countries, and according to that you can easily identify that one how and which country are more improved, and where lifestyle is very good, and where GDP is more good. You can identify that one. And in here basically they are using the population, and here basically compare the which country's population is more, which country is less. They are taking that one. You can see by seeing that one you can easily understand that Germany is the most populated country in here, and this 25.8 basically this is the another country. And if you compare with this country, Germany, Turkey, finance, France, United Kingdom, then you can see Germany is the most populated if you compare with these countries. So pie chart is basically really helpful to understand all the data in a percentage wise. Then again I am just taking that Gapminder dataset, and that's GDP dataset, and then I am using the another new chart that is called the sunburst chart. How it is, again it is more like the heat map kind of things. In that heat map is basically life experience, and this light color is basically highly experienced and highly good condition of those countries, and the deep color and the dark color, these are the underdeveloped countries. So if I am just taking that same data set, I am just taking the year of 2007, and I am just taking that Gapminder data set, then I am just passing that what I am passing it here, px.sunburst. I am just want to make the sunburst chart. Then I am just using the continent and the country, and in the first round I am using the continent, and the outer round I am using all the countries there of that continent. Then I just take the all the value of pop means population of those countries. Then I am just using the color of the life experience of there, and then hover. If you are just hover there, then you can see the alphanumeric number. What is the alphanumeric? That means alphabet is also there, integer value is also there, so that's why they are using the alphanumeric. So by seeing this chart in the first round, if we see the Europe is the most good condition if you compare with the Asia, Africa, Americans. So this is the best continent in Europe. And Africa, this purple color is basically, this is the most problematic continent, because this is color used the deep color. So by using this deep color, this purple color, these are basically the problem of the country. Those life GDP is less, their lifestyle is also less. If you see the European and most of the country, the American countries, their condition is too good. But in here in Asia, that Asia condition is moderate. But if you see in here, the Japan, this country is most advanced country. This is the only one country which comes the yellow color in Asia continent. So this kind of the data inference, you can do it by using the sunburst chart. Again, guys, this is the very interesting chart. This is called the tree maps. Trees, we already have the concept when we did the tree concept in DSA part. How it takes one by one, it likes that. So in outer world I am using the one wall, then just taking the outer world, the PyData Explorer. Just beneath that I am using the continent, and I am using the Asia, Africa, America, Europe, and I am using that one. Then inside all the continent, all the countries are using here. So by seeing that, we can easily see, again, if you see the life experience, the light color, the light yellow color, that is the best good position, the best position. among all of them. So if we see the America and Europe, they are in the best condition. If you see rest of the continent, and Africa is the only one continent that is one of the worst condition. By seeing this tree maps, you can see in this tree map they are using the Africa, the purple color, and all their countries, those are the purple color, except Egypt, Morocco, and Algeria. So rest of the countries are the problem area. So guys, if you are just know to how to create the heat map, how to create the trees maps, then you can easily identify the different data set and their problem statement. These are the weapon. Now we can using the plotting, how we can the plot import plotly dot express as px, and then we are just using the tips dataset, and in x-axis we are just using the total bill. Yes, this total bill is here, and y-axis I am using the time here. Then orientation is equal to h. Orientation means h means horizontal, and if I am using v, orientation is equal to v means vertical. If I am using v, then this chart will going to be vertically present here, and though I am using the horizontal h here, so this chart created horizontally, and I am using the color is the smoker. What is the which color? This color is the smoker color I am using here. And if I am just making this chart, by seeing this chart about the tips chart, what we can interference the data, we can easily see in the dinner time. If you compare this dinner time data set, and that means number of total bills is more in the dinner time. So as a restaurant owner, if you are running the one of the your restaurant, then most of the expensive dishes you can make it in the dinner time, and most of the people or the worker you can use it on this dinner time. And the problem area is the lunch time. What you can do that in the lunch time, you can offer the different kind of offer, you can make it, you can use less this on there, so that the you are not in the loss condition if you are using the less manpower, less expensive food menu in this lunch time. So by using this kind of a chart, we can easily identify this data and their problem statement as well. Then again, I already explained in the last video what is the heat map. Heat map is basically identify according to the color. This purple color is the count, the which is the less count, it starts from 0, it is the deeper color, and as soon the number of increasing, that number is also 5, 10, 15, the number is also increasing here. So by seeing this heat map, we can easily understand. If we just hover the mouse in the yellow color, then you can see that count is equal to 19. In the I am using basically Irish dataset in here, and in here you can see that the sepal length and pedal length is also mentioned there, and the width and the length is also mentioned there, and then count is 19. And if you go in the purple color, you can see that count is 1. So basically in this category, in this sepal length and sepal width, most of the flower is present here in this data set, and in this particular deeper color area only these are the less number of the dataset is present in this here. So how they can use or make this chart here, the px dot destiny underscore heat map, then they are passing the data frame, comma x is equal to sepal width. This x-axis they are taking the sepal width, y-axis they are taking the sepal length. That's it about this heat map. Again, if you try to understand in a very narrow way, very smaller easier way, I am just passing one array here, 2D matrix I am just taking it, and if you see in this angle wise, I am taking the small number 1. So in this all the small number area they are using the deep color, and rest of the area, the 40 and the 90, this is the maximum color. You can see this is the maximum light color is used here. That's how the heat map basically represent their data set. Now then I am just taking if the cars here, one of the location, that what is the cars here, it is there, so you have to understand that one. So this is one of the dataset what is there. I will explain this dataset in next program. If you see, suppose you have the Ola or the Uber, Ola, you are the owner of the Ola cab. So what it is your aim? If you are the owner of the Ola cab, basically your aim is to give the best service. How you can identify the different location in Delhi? Suppose in Delhi area, Gurgaon area, they have the different office areas, and they have different time frame area. So what you want to do, basically, suppose the Noida, that is the the rush hour is like 9 to 10. Most of the people, they used to go in the office in 9 to 10. Suppose in that time, what you want to do, you want to just provide maximum kind of the cab on that particular time. Suppose in the Gurgaon area, that is shopping area, basically in the evening time, just take an example. In the evening time, people used to go in the different mall is there for the shopping. So in the evening time, what you will do, you try to cover, you try to provide that cab on that evening time, that Gurgaon area, so that people can promptly or easily or the quickly they can get the cab in the office time in the Noida area, in the shopping time at the evening time in the Gurgaon area, so that your cab can be run more way, your cab can be booked most of the time in a day, so that you can generate more business. So how we can do that at the scatter the map box, I'm writing down this kind of the program in here, and I'm using the latitude and the longitude from the Google map or the map. LAT is equal to centroid lateral underscore lat, and the LON basically longitude. I am taking the centroid longitude, and I am using the color of the peak hour. What is the peak hour here? So I'm just seeing in the right hand side, the 0 stand for at night 12, then 1 2 3 4 5, 5 in the morning, 10 in the morning, 15 is stand for afternoon 3, 8 is at night, and this particular 12. So most of the color of the starting of the day, that is the blue color, these are the blue color. If you hover on this particular point, then you can easily understand this blue color is stands from, this is the morning 5, this is the rush hour. So this blue area, these are the rush hour. On this particular area, you can just try to be give that card on that particular location. And this color, the evening time, this red color, the dark color, but you try to provide your cab on that particular time at 8 p.m. So you have to understand, as a business manager, you have to understand the areas concept, and so that you can increase your business in different way by using different kind of the chart. So I have the px dot data dot elections. Say I'm just taking the one election data set. What is that? What basically I this data set describe about the different kind of district name is there, and then they have the different location is there, and the number of the bills is there, and who is the candidate winner. The name is also mentioned there, and the result is also there, and district, these are the district ID. This is basically the district election data set, and by using this data set, I am just creating one map. Again, it's the tile map. What is that one tile map? Again, they are using that color concept like the heat map. If you are hovering on those point, if you see this one, the light color is basically the maximum number of the vote, and which district is also there, it mentioned, and which location and how many voter is also there. So light yellow color, that is the maximum voter. If you see that 6408 is there, and if we hover in the purple area, those are the less voter is there, so those are the deep color. So by using this map, they are using this data set. So how they are making the data set, how they are figuring up that one, then they are taking the geo johnson is equal to px data election data set underscore geo json, and they are taking this data set, then they are just passing it at the data frame, then they are using the Bargaon, then location, they are taking it as a district, and there are different parameters also there. Centered is basically they are taking the latitude and longitude of the geographical map, and they are using the zoom size is 9, means you can make it zoom slower or smaller or the bigger. In such a way, you can just check that in which area, that how many voters is there, who win the vote. So you can identify this kind of the problem statement by using this map. Then again, it is the in world map, and this is called outline symbol maps. And if you see in here, there are 5 continent is here present: Asia, Europe, Africa, America, and the Oceania. And we are using px dot scatter geo underscore geo. We are just passing the data set, and we are using the location, the ISO alpha, this and the latitude longitude I am using it here, and I am using the color is the continent. This continent color it is using on this map, and hover name is equal to country. If you hover on this point, you can see the country name as well. Then size is equal to pop. Size is equal to pop means they are taking the population column, and then animation underscore frame is equal to year. They are taking the year wise, and the projection is natural earth. Basically they are taking that this is a natural kind of the art. If I just run this animation, you you can see this area in Asia area, you can see that going to be grow up. This bubbles is going to be grow up little bit. That means in the from the year of 1952 till 2007, that most of the bubbles are increasing in this location. That most of the population is basically increasing India, China, this kind of area, and some of the this purple area is like the Brazil and the United States. Some of the population that is also increasing in this particular area. And again I am using this the chloropleth map. This is also one of the interesting map. If I just run the animation, guys, see the animation, they are changing some of the America, Europe, and Asia and Oceania, they are changing their color. What does it basically means? It basically means the dataset I am taking from 1952 till 2007. So what that they are doing, that they are taking again the gap minded dataset, they take it, and then they are just px dot chloropleth, basically the name of the plotting, and then they are using the location iso underscore alpha, then color is life expenditure, the experience, you can say hover name is equal to country, I already explained that one, and then animation frame is year, in which year they are taking it and how they are increasing that one. So basically in this area the problem statement is there. So problem statement is that the how from the 1952 till 2007 which of the continent are basically improved. If I run again initial stage, we can see the America and this part of the Oceania and the Asia part, they are in a more deeper color, and right now they are going to be more lighter yellow shade. The Oceania, northern part of America, and this northern part of the Asia, this area, they are changing the color. That basically that country are already got the development till from 1952, when the year is going to be increased according to the time they are improving. And if you see the African country, they are still in a danger zone. Now I'm just recapping some of the plot of the seaborn, and quickly I'm just taking the seaborn library and I'm just using the tips. Tips is basically that this same tips dataset, and again you can see that cns sns dot rail plot, I am using the rail plot here. But if you see this one, you can easily understand on this plot area, most of the bill is generated, or most of the tips is given here. Only some of the people they are giving the more than 8 pound of the tips in this particular area, that is the outlier. But according to that, as a business manager, you have to understand in this particular area this time frame and total number of bill 30, and the tips is just going to be given in this lower amount of the bill, and the higher amount of the bill in your restaurant, that is less, and in their tips amount is also less. So if I am using the rail plot, and if I am using so many of the parameter, if I am using the x in the tips, in x parameter I am using the tips, and the y parameter I am using the total bill, and I am using the number data is equal to a, hue is equal to day, and I am taking all the day, hue is another parameter, and then I am using the smoker style, then size is equal to size. If I am using this kind of things, this plot is basically not interference any of the information. By seeing these guys, you cannot understand, you cannot take any kind of decision. So yeah, as a data scientist, you have to understand that which particular plot you have to use it in which condition. This is basically another again important the scatter plot, how we I am taking the iris data set, and I am just passing the sepal length and sepal width, and again I am using the data is equal to iris. So if I am just using that one, then by using that one we can easily understand in this particular location 6.5 till 3.5 most of the data is present here. That means in iris all the flowers category, their sepal length and sepal width, sepal length and the sepal width is just lies this area, this particular area. And this is the hotel how I am taking that one, imported numpy as np and x is equal to np dot random random. I am just taking the 10 random number, and I am using the that sns dot cat plot, I am using it, x is equal to day, I am x-axis using day and y-axis I am using tips. And then if we are just seeing that one, we can easily understand in the Saturday and Sunday most of the tips is given these two days. If you compare with the Thursday and Friday, in this area bill number of the bills is also less and their number of the tips is also less if you compare with the Saturday Sunday. So data, basically you have to understand, data basically speaks a lot. So that is actually the proof of that. And if we are just using the joint plot, these kind of things I already explained in my previous video, but in here I just want to show you the kind I am using here, the hexaplot. Hexaplot, it basically means the 6 side is there, and in here sns.joint plot x is equal to tips, and I am just passing total number of bills, and the tips I am just passing y-axis. So by seeing this chart we can easily see that these are the key area. This deeper color in here in hexaplot, in this area most of the dataset is lies here. It means most of the your bill is generated in this particular area, and the tips is also given most of the this area, and only few tips is given in this particular area. This area basically the scope of improvement of your business is there. So you have to think about that, what kind of decision that has to be taken by the manager and by you as a data scientist. You can running some offer, you can just call them, you can just offer them the family offer. So you have to think like that way so that your business can be increased. So again, if you see the pair plot in the iris, I already explained. In the pair plot you can see if the all the data set is like the in angle wise, this is the x-axis, this is the y-axis. If it is goes in the best fit line in the angle wise, that is means your data is positively correlated. So if you see that most of the data set is positively correlated in here. So what is the meaning of the positively correlated? If the both the things, if the suppose if your age is increasing and your salary is increasing, that means both the field is increasing. So in that case, that is called positively correlated. And if you take the data set of the car, if your horsepower is increasing and your mileage is decreasing, suppose one is going to up and another one is going to down, that is called negative correlation. So after seeing this data set, we can easily understand that iris data set, iris cloud data set is basically most of the area that the positively correlated, because it goes from left to right in the best fit line in the upper direction. So that is called the LM plot. What is called the LM plot? I am just using the x is equal to total bills and y is equal to tip, and data is equal to tips is tips and color is equal to day. So I am just taking the total number of bills x-axis and the tips is in y-axis, and I am passing the day Sunday, Saturday, Thursday, and the Friday. If you see through this data set, you can easily understand these 2 days, the Saturday and Sunday and Saturday is comparatively Thursday and Friday number of bills is more, and in their tips is also more, and their best best fit line is also there. That means the people are coming there, they are giving the tips and they are generating the business. And then this two particular area, their bill is less. Of course, if the bill is less, people is less, their tips will be going to be less. So according to this diagram, you can just also inference this kind of the information, and that is also in a bigger representation and the same thing. And that's all guys about the pie plot and plotly, you can say. And I think there are a lot of information is there and a lot of plot I am using here. So guys, just remember that this kind of plot, it will not work in every time, but as a data scientist, if you have to be understand all the plot, because if any of the organization just they're coming and they're swing their plot in such a way, and as a data scientist you do not understand that kind of things, that basically creates a very bad impression in any of the organization. So you have to know all the things, and according to that you can just make your plot so that you can interference the data and you can solve the problem. And thank you so much, and wish you all the best for happy learning and your happy career. And please stay tuned with the PyData Explorer. Thank you.